Right, got the projectiles question from the M2 international paper, October 2018. It says time t equals 0, a ball is projected from a fixed point A on a horizontal ground, hit a target. It's projected from A with speed u at an angle theta to the horizontal. So this horizontal component is u cos theta, and the vertical component is u sine theta. Time t equals 2 seconds, the ball hits the target. The instant when it hits the target is travelling downwards at 30 degrees below the horizontal with speed of 12. So when it hits the target, it's still going to have a horizontal component of u cos theta. I'll call the vertical component v. I say it hits the target with speed of 12, 30 degrees below the horizontal. And we're going to find out what the theta and the u are. So looking at the velocity when it hits the target, it's going down to the right, speed of 12, angle of 30 degrees. The vertical component, this is the v really, and that's going to be the same as 12 times sine 30, and that's equal to 6, because sine 30 is a half. The horizontal one, u cos theta, which is this, well, that's going to be 12 cos 30, adjacent side of the triangle. Cos 30 is root 3 over 2, so this is 6 root 3. If I use v equals u plus at, I'd like the v in terms of u really. So I'm looking at the vertical component for the journey from here, from A to T. The final vertical component is minus 6. The initial vertical component is u sine theta. So v equals u plus at. Give me u sine theta is 13.6. When I look at these two equations, what I can do, I've got u cos theta and u sine theta. I can square these and add them together. So I get u squared cos squared, u squared sine squared. Well, that's just u squared because I can take u squared out as a factor. And so I have u squared times sine squared plus cos squared. And that's going to be this squared plus this squared. So add these together, do the square root, 17.1. If I divide them, u sine theta divided by u cos theta, I'll get tan theta, because the u's will cancel. 13.6 divided by 6 root 3, give me theta is 52.6 when I do tan to the minus 1. Then what the height of the target, we call it h. I can use s equals vt minus half at squared. I know this is minus 6, so minus 6 times 2 was a half, minus 9.8 times 2 squared. Give me 7.6. I could use s equals ut plus half at squared. I know the initial vertical component now. U sine theta, so it's 13.6 times 2, half of minus 9.8 times 2 squared. I could even use v squared equals u squared plus 2as, 0.8. And then it wanted the time for which it's more than h meters above the ground. So the time from going from here to here, I'm going to use s equals ut plus half at squared, going for the journey from A to T. And there are two times when the displacement is 7.6. So I put 7.6 equal to 13.6, the initial vertical component, minus half at squared. Get a quadratic. I know that t minus 2 is going to be a factor because when it hits the target, t was equal to 2. So the other factor must be 4.9t minus 3.8. You could just see it in the calculator, of course. So the time, that's when t is equal to 2. That's the time of t is 3.8 over 4.9. So the time it's above 7.6 meters. I've got to subtract and find the difference between the two. 60 over 49. I think a slightly clever way of doing it, if I consider the journey from the two places where it's 7.6 and use s equals vt minus a half at squared, the displacement will be 0 from the journey from here to here because it's the same height, and minus 6 minus half minus 9.8 times t squared. Give me the same answer. And because you can cancel out a t divided by t here because t is not 0.